going to go over the 7.1 through 7.4 review. For problem like number 1, you're simply going to put it in the calculator and plot the points from the table. Y equals, we got 5, 1/2 to the x minus 8. You got your table. 0, -3. -2, 12, -1, 2, 0, -3. This is what the graph looks like on the graph that we can show. If you go to the calculator and you look at the graph, you can see that it starts to taper and level off here. Which is at -8, so your domain, instead of all x, is such that x is all real numbers. But your range is going to be, instead of all y's, such that y will be greater than 8. Number 2, put in 1/2, 3 to the x plus 4 power minus 5. Look at the graph of that. See that it's going to taper off down here at -5. Our table. You have points that you need to plot on the graph, as many as it will fit. If you don't change the scale and you go by ones, then this is all that you'll be able to show. Again, your domain is, instead of all reals, your range would be the y's. Y would be greater than 5, because it's not going to go any lower than 5. For number 3, we start out with 12,000. That'll be our A. Our base, since it doubles, is going to be 2 to the x power. That'll calculate y, will be the number of bacteria after x number of days. So how many bacteria will there be after 6 days? 12,000 times 2 to the 6th. 12,000 times 2 to the 6th would be 768,000. Number 4, college with a graduating class of 4,000 in the year 2008 predicts that its graduating class will grow 5%. Write an exponential function model the number of students that will be in the class t after t years if it grows 5%. The equation will look something like this. Start out with 4,000, it'll grow at 5%, so you 1 plus 0.05, and then x will be the number of years after 2008. Number 5, we have to get like bases. So since 64 is equivalent to 4 to the 3rd, we'll replace 64 with 4 to the 3rd, and then we'll multiply our exponents together, and we'll get x plus 35 and 4. And make sure you multiply 3x minus 9, so then you can drop the bases off. we're left with x plus 35 equals 3x minus 9. Subtract 3x minus the 35. We get negative 2x will be equal to negative 44. Divide by negative 2. Means x would have to be 22. Number 6, we still need to get like bases. 64 is 8 squared. So 1 over 64 is the same as 1 over 8 squared, which is also the same as 8 to the negative 2. So when we multiply our exponents together, we get 8 to the negative x plus 6, which would be equal to 8 to the 9x minus 2. So you drop your bases. And solve for x. Subtract 9x. Subtract 6. We get negative 10x is equal to negative 8. Divide by negative 10. X would be 8 over 10, which reduces to 4/5. Number 7, again we need to get like bases. A half can also be written as, since that's 2 to the first, be written as 2 to the negative first power to the x minus 3. And 16 is 2 to the fourth. So when you multiply your exponents together again, you get 2 to the negative x plus 3 would be equal to 2 to the 12x minus 4. Again, drop your bases. Solve for x. You get negative 13x equal to negative 7. Divided by negative 13. X would be a positive 7/13. Number 8. 1/9 is the same as 1 over 3 squared, which is the same as 3 to the negative 2. Multiply your exponents again, we get 3 to the 6x minus 2 be equal to 3 to the negative 2x minus 2. Drop your bases. Solve for x. End up getting 0 on the right side, equal to 8x, so x must be 0. Number 9, we want an exponential function. Since we know the y-intercept is 5, this is going to look like y equals 5 times b to the x power. We need to find b, so we're going to use this for x, this for y, to temporarily plug them in and help us find the value of b. So this is how we'll set it up. We'll divide both sides by 5, and then we'll take the fourth root of the answer, 625 is equal to b to the fourth. We'll take the fourth root of both sides, and fourth root of 625 is, fourth root of 625 is 5. That would be our b. So we'll take that back up here, and our equation would be y equals 5 times 5 to the x power. Same process for number 10. 3/4 is our y-intercept, so that'll be our a. Plug in 2 for x, 36.75 for y, and solve for b. So what we'll need to do is multiply both sides by 4/3 to cancel. In the calculator, we'll type 4 divided by 3 times 36.75. That comes out to 49, which will be equal to b squared. So we'll take the square root, both sides. B would be 7. So that means our equation is y equals 3/4 7 to the x power. Same process for number 11. We're going to divide both sides by negative 0.2. Then we take, and we can change this b to the negative third to 1 over b cubed. And a couple options that you can do right here. We can actually take the cube root if we want to. The cube root both sides would give me 2.5, but that would be equal to 1 over b. Multiply both sides by b, and then divide both sides by 2.5. We get b equal to 1 over 2.5, which is the same as 2/5. So our equation would look like y equals negative 0.2 times 2/5 to the x. Same process for number 12. Divide both sides by 0.7. 3.5 divided by 0.7 is 5. So 5 is equal to b to the half. B to the half is the same as the square root of b. And so I need to square both sides. Means b is 25. There's my equation. Number 13, 400 is the same as 20 squared. 1 over 20 is the same as 20 to the negative 1 power. So then that would leave us with 20 squared being greater than 20 to the negative 7 minus negative 7x minus 8. Drop the bases. 2 is greater than negative 7x minus 8. Add 7x. Subtract 2. 7x is greater than negative 10. So x is greater than negative 10 over 7. For 14, 1,000 is 10 to the third. 10 to the third to the x. So here we have 10 to the 2x plus 7. 2x plus 7 is greater than 10 to the 3x. So that means 2x plus 7, when we drop the bases, is greater than or equal to 3x. I'm going to do it a little bit different. I'm going to take the x to the right, minus 2x, so I can do this in one step. 7 is greater than or equal to x, or x less than or equal to 7. Number 15, 16 is 4 squared, so that's the same as 4 to the negative 2 to the 3x minus 4. 64 is 4 to the third. We multiply our exponents together. We end up with 4 to the negative 6x plus 8 is less than or equal to 4 to the 3x minus 3. Drop your bases. Subtract 3x. Get negative 9x. That's 8. Less than or equal to negative 11. Divide by negative 9. Then we're reversing inequality since we divided by negative. X is greater than 11 ninths. 16, 8 is the same as 2 to the third. So this would be the same as 2 to the negative third to the x minus 6. Less than or equal to 2 squared to the 4x plus 5. So that means that 2 to the negative 3x plus 18 would be less than or equal to 2 to the 8x plus 10. Drop your bases. Subtract 8x. Negative 11x. Subtract 18. Less than or equal to negative 8. I've got negative 11. X greater than, I've got to switch the sign again to positive 8/11ths. is 1 over 36 is the same as 1 over 6 squared, which is 6 to the negative 2. 216 is 6 to the third. Well, that leaves me with 6 to the negative 2x minus 16, less than or equal to 6 to the 3x minus 9. Negative 2x minus 16 needs to be less than or equal to 3x minus 9. Subtract 3x. Negative 5x, add 16. Less than or equal to 7. Divide by negative 5. X should be greater than or equal to negative 7/5. After some messing around on the calculator, figure out that 128 is the same as 2 to the 7th, and 1024 is the same as 2 to the 10th. So rewrite it as 2 to the negative 10th to the 2x, which would become 2 to the 7x plus 21, which would be less than 2 to the negative 20x. Drop your bases. 7x plus 21, this would be less than negative 20x. Add 20x to both sides. Negative 27x. Subtract 21 from both sides. We get negative 21. Divide by 27. 21 over 27. Number 19, at a specific time, there are 216 to the T plus 18 bacteria of one type and 36 to the 2T plus 8 bacteria of another type. When will the number of each type of bacteria be equal? Well, the T's will be equal when 216 to the T plus 8 is equal to the 36 to the 2T plus 8. So 216 is 6 cubed. 36 is 6 squared. So that means 6 to the 3T plus 24 will be equal to 6 to the 4T plus 16. Drop the bases. 3T plus 24 equals 4T plus 16. When T is, and we'll subtract 3T this time. That gives me just a positive T equals, subtract 16. 16 from 24 is 8. Time would be 8. Let's get to some easier ones. 2 to the 6th equals 64. 3 to the negative 4th equals 1/81st. 25 to the half should equal 5. And it does, so the square root of 25 is 5. 32 to the 3/5 should equal 8. To reverse the translation, you get log of base 3 of 81 should be equal to 4. Log base 3 of 1/81st should be equal to negative 4. Log base 1/4 of 1/64th be equal to 3. And log base 776 of 6 would be equal to 1/5. To evaluate this, the easiest way would be to set it up to some number x, so that you can write 2 to the x equals 1/16. 1/16 is the same as 2 to the 4th. 1 over 2 to the 4th. So 2 to the x equals 2 to the negative 4th. That means x equals negative 4. We don't really have an x. Just know that this must equal negative 4. Same process for 29. 1/3 to the x equals 27. That means 3 to the negative x equal 27, which is 3 to the 3rd. So negative x equals 3. X must equal negative 3. Or this actually equals negative 3. 9 to the x equals 1. Well, the only thing that equals 1 is going to be when x is 0. 1 is the same as 9 to the 0. 8 to the x is equal to 4. That would be 2 to the 3x equals 2 squared. So that means 3x equals 2, x equals 2/3. This actually equals 2/3. We can skip 32 and 33. Let's go to 34. So 120 is going to represent our loudness in decibels. So 120 is equal to 10 log base 10 of some number r. Divide both sides by 10, and then we'll get 12 is equal to log 10 of r. And we'll write that as 10 to the 12 is equal to r. We put that in our calculator. And actually that's too long, so we'll just leave it as 10 to the 12. Number 35, we'll take 4 to the x plus 5 power is equal to 256. 256 is 4 to the 4th. So x plus 5 must equal 4, which means x equals -1. Six, 5 to the 5th is going to be equal to 3 minus x. So 5 to the 5th is 3,125. We'll switch the x and the -325. So that means x is going to be equal to negative 3,122. Number 37, we have a double log. So we can just set up x minus 5 equal 3x minus 25 minus 3x from both sides. Add 5 to both sides. -2x equal to -20, so x must be 10. For log inequalities, we've got to pay attention to our inequality signs. On a less than, then we need 8 to the first, less than -6x or greater than, which means be greater than 0. We can divide everything by -6. We get 0 needs to be less than x, which needs to be less than -4/3, which is impossible. Except, we forgot to do one thing. Since we're dividing by negative, we have to reverse our inequality. And now it's not so bad. So x needs to be bigger than -4/3, but less than 0. So when you put anything, any value of x will be negative, and you plug it in for x, the -6 times it will turn it to positive, and so you're okay. On a double log, again, we can get rid of the bases, get rid of the logs. X plus 2 must be greater than 6x minus 6 minus 3x. Solve for x, add 3x to both sides, 4x, subtract 2 from both sides, get 4, so x to be greater than 1. However, we have to pay attention here, because once x becomes bigger than 2, we'll end up with a negative number. We cannot take the log of a negative number. So x, 6 minus 3x equals 0. Subtract 6, negative 3x. That's our limit on the other side. So 1, x needs to be between 1 and 2. Another less than, so that means x plus 7 would be bigger than 0 and less than 11 to the first. Subtract 7 in all three areas. And we get 4. So x needs to be somewhere between negative 7 and 4. 41, again we have a double log, so x plus 6 must be less than 17. That means x has to be less than, subtract 6, 11. And x can be less than 11, but we can't let x be any less than negative 6. That's the limit for how low x can go before we take the log of a negative number, which we can't do. Here we have a double log. Lose the logs. Subtract the 5x. Add the 1. Get negative 3x greater than negative 15. Divide by negative 3. X, we got to reverse the inequality. Less than 5. But let's double check and make sure. X can be less than 5, but how much less? Set the first one equal to 0. X would be 1/2. Can't be less than 1/2 over here. 5x minus 16 equals 0. Means x, add 16, divide by 5. So it can be no less than the bigger one of these two is 2 1/5, 3 1/5. So it has to be bigger than 16 over 5. Same situation, same logs. Drop the logs. X minus 5 needs to be greater than 2x. So I'm going to subtract x, make it a little bit quicker. Negative 5 would be greater than x. So that means x needs to be less than negative 5. But anything less than negative 5 is going to cause that to become negative. Anything less than negative 5 is going to be a negative number. 2 times a negative number is going to be negative. You can't take the log of a negative, so there is no solution. I don't expect you to be able to set up number 44, but the population is going to double every 12 years. So if y is our years, then once it reaches 12, 12 divided by 12, which will be 1. So 2 to the first will make it double. So we want to know when and what amount of time will the population be 20 times what it is now. We divide off both sides by p, and the p can go away. So you're just left with 2 to the y over 12 equal to 20. The set that up as a log. That means that the log base 2 of 20 would be y over 12. Multiply both sides by 12, and we get 12 log base 2 of 20 would be equal to y. And we'll leave that as our answer.